All right, now we're balancing a redox reaction, and we can see that we are in acidic solution. Now we want to determine the oxidation number of every element that's changing oxidation number. That would be chlorine. Here it has an oxidation number of -1, and we're going to go through the steps to determine the oxidation number of chlorine and the products. So the sum of the oxidation numbers has to equal our net charge, which is 0. Hydrogen is always +1. Chlorine is what we're trying to find out. And the oxidation of oxygen is -2. So the sum of these has to equal our net charge, which is 0, which means chlorine -2 is equal to 0, or the oxidation number of chlorine is equal to +1. All right, now we'll look at chromium here and in the products. In the products, since it's a monatomic ion, we can immediately determine that our oxidation number is +3. And we're going to do the algebra to determine the oxidation number of chromium in chromate. And we work through our algebra. Again, the sum of the oxidation numbers is equal to our net charge, which here is -2. We see that chromium in the reactants is +6, and the products is +3. The next step is to balance those elements changing oxidation number. 1 chlorine, 1 chlorine, 1 chromium, 1 chromium. We have to do this step before we consider electrons. So we want to figure out the electrons lost and gained for the equation as written. So we look at chlorine. For chlorine, we are going from an oxidation number of -1 up to +1. That's 2 units, so that's going to involve 2 electrons. For the chromium, we're going from +6 to +3. That's a change of 3 units. Therefore, that's going to involve 3 electrons. We want to match the number of electrons lost to electrons gained. So we look at the number of electrons thus far. The lowest common multiple of 2 and 3 is 6. So we want 6 electrons lost and 6 electrons gained. So we multiply the coefficients associated with chlorine by 3 and the coefficients of those chemicals associated with the chromium by 2. So now we have the number of electrons lost equal the number of electrons gained. The next step is to look at the charge. And we are in acidic solution, so once we figure out the charge on each side, we're going to balance the charge by adding H+. For this reason, we're going to ignore the H+ here when we're initially calculating the charge. All right, we have 3 of the chloride ions, and we have 2 of the chromates, net charge -2, so that's -3 plus 4. Thus far, and again, we're going to ignore the hydrogen, we have a -7 charge on the reactant side. On the products side, we have 3 hypochlorite, no charge, and 2 of chromium-3 ions. So we have a net charge of +6 on the product side. In order to balance the charge, we need to add an appropriate number of H+ ions. Again, we use H+ ions because we're in acidic solution. So to match charge by adding H+, we're going to have to add it to the reactant side, and we're going to have to add 13 H+ ions. So by adding 13 H+ ions, we now have a net charge of +6 in the reactants and a charge of +6 in the products. So we're now balanced for charge. Next step is to balance the oxygens by adding water. All right, if we look at the reactant side, we see oxygens are only in the dichromate or chromate ion, and there's 2 times 4, 8 oxygens in the reactant side. On the product side, we have oxygens only in the hypochlorous acid. Again, we're going to ignore the H2O here because we're going to use that to balance the oxygens. So thus far we have 3 oxygens. In order to balance this equation for oxygens, we're going to need 5 more. Now, if we've done everything correctly, our hydrogens will also balance. 13 hydrogens in the reactants. In the products, we have 3 plus 10, 13 hydrogens. We're done. We're balanced.